Hello everyone. So this is the video lesson 24, and in this video lesson we are going to discuss the one of the most important application of the inclined film interference with the special case of the Newton's ring, and that application is the wavelength determination of any monochromatic light source. So by the help of Newton ring arrangement we can determine the wavelength of a light source having the single wavelength. Okay, so now let's see the working formula for it. Now we already discussed the diameters of the rings, the diameter of the bright ring and the diameter of the dark ring. Okay, so now in this working formula let's concentrate on the dark ring. Okay, suppose that there is a two dark rings, one is the order of nth order and other is the n plus pth order. Okay, so these are the two rings and their diameters are represented by dn and dn plus p. Then we can write the diameter equations for these two dark rings given by these two formulations. Okay, so now let's subtract these two, and in this way we obtain the wavelength lambda is equal to dn plus pk square minus dn square divided by 4pr. Here p is any integer value. Okay, so this is the working formula for this experiment and also very important formula for many other numerical calculations. Okay, so in order to determine the unknown wavelength, first of all we take the source of that unknown source. Here we put the source, and the source, by the help of this source there is a arrangement of the normal incidence on the set of the plane glass plate and the plano-convex lens, and by the proper adjustment of the experiment we obtain the Newton's ring. Okay, so in this experiment first we focus the eyepiece of the microscope on its crosswire, and then we obtain the Newton's ring in the field of view by raising up or lowering down the microscope with the help of its screw arrangement. And now the lens is slightly displaced on the plate so as to obtain the center of rings at the point of intersection of the crosswire. Then the microscope is moved horizontally. Okay, and suppose that we left the microscope, we move the microscope on the left side with the help of its screw, and simultaneously we count the number of rings, and the crosswire is made tangential on the nth ring. The reading of microscope is noted down, and now then the microscope is slowly moved to the right side and its reading is noted, keeping the crosswire tangential on the rings. And similarly we note down the readings of different rings, dark rings, and the difference in reading on the two sides of the ring will be its diameter. Okay, so this is the simple procedure of this experiment, and here I try to plot the pattern. Okay, so this is the reflected case, so the center is dark here, and in this experiment we focus ourselves on the dark ring. However, this formula is valid for the both types of the rings, either bright or dark. Okay, so here I take this black ring, means dark ring, and let the order of this dark ring is n. Okay, now let's say another higher order dark ring, and this order is given by n plus p, where p is the gap of order between these two dark rings. Okay, so the diameter is noted down by the help of crosswire and microscope, The diameter of nth dark ring and the diameter of n plus pth dark ring is noted down, and in this way we we uh, we uh, we calculate the different diameters of the different orders of the both side of the center, one of the left side, other is the right side, and in this way we get a sufficient data to plot the graph. A graph is then plotted between the square of diameters and the number of rings. Here on the y-axis we take the square of the diameter, on the x-axis we take the order of rings, and the graph is the straight line. Okay, the graph is straight line, and we take the slope of this line. The slope is given by dn plus pk square minus dn square divided by p. Okay, so the slope value is given to the working formula. Okay, and by placing proper value of the length radius of the curvature and the slope of the graph, the wavelength can be calculated. Okay, the radius of curvature of the plano-convex lens can also be calculated, can also be experimentally determined by the help of the spirometer. Okay, so either it is calculated by the spirometer or it is given, and in this way we can obtain the wavelength of any monochromatic light source. Thank you.